So you have some time and you want to get a jump on your classes next semester. 20 years ago, if you wanted to do that, the best advice I could give you would be grab a textbook and start reading. That's still good advice. Absolutely, read the textbook in detail and read ahead. But this is the 2020s. The pandemic changed everything about education and online resources. So it's a good idea to talk about, say, some ways you can get ahead of your math classes in this new environment. Now, of course, the advice changes depending on where you are in your math journey, and for each stage, my advice is going to be a little bit different. Probably the most common spot where someone is going to be in when they start asking questions like this would be in a class like, say, calculus. Calculus is one of those weird classes where, depending on your high school, you could take all the way up through multivariable calculus or even differential equations before you graduate. Or you might be in college when you start learning Calculus 1. Thankfully, calculus is more or less standardized across the United States, thanks to books like James Stewart's Calculus Early Transcendentals. For classes like, say, pre-calculus, calculus, algebra, and say all the way up to differential equations, the most important thing to do is to work a lot of problems. That's really the only way to learn a math topic. You basically want to get to the point where everything's reflexive, and if you watch a kung fu movie, you see them practicing over and over again for years before they can, fight like, I don't know, Jet Li or something. If you want to be the Jet Li in mathematics, well, you got to do a lot of problems and a lot of repetition. And so having a good textbook is, pretty good for that sort of thing. And so the best resources for problems is going to be, say, your large standard textbooks, like James Stewart. These books have hundreds of problems you can work on, and you can check your answers in the back of the textbook too. If your class requires you to have a copy, then by all means go purchase the latest edition. But if you want to save some money, go back a few editions and pick up an earlier version for, under $20. Learning calculus or any of these other subjects doesn't have to be expensive. It only gets expensive when you're actually taking the class. But before you can work on problems, you need to learn something about the topic. You could do this by reading the relevant sections, or you can leverage a platform you're already on. YouTube. Since the pandemic, the sheer number of places where you can find basic mathematics lessons has really proliferated. People like Michael Penn has loads of lessons that you can watch, and also Black Pen, Red Pen too. On my own channel, I have a playlist for like differential equations, and if you want sort of more upper division sort of coursework, I have things on, say, control theory, machine learning, and other functional analysis type things too. I usually lean towards more upper division mathematics and graduate student math than I do the earlier stuff. Now, if you want apps to help you out, then there is the free Khan Academy app, which gives you lessons ranging from, say, preschool math all the way up through differential equations. I actually use it to teach my kindergartners basic addition and other basic math content. And let's not forget Brilliant.org, which has a great app for learning all sorts of topics from, say, programming to mathematics and, well, more. They have sponsored me in the past, but this video isn't actually sponsored by them at all. I think it's a great way to gamify your learning experience if you want to go that way. And you can also find an affiliate link in the description of this video if you want to go that way. Now, if you know any good resources, then please do leave a comment in the video. There is a lot out there, and in a single video, I can hardly scratch the surface. So this will get you lectures and problems to work. The rest really comes down to making a schedule for yourself and sticking to it. Say an hour a day every workday would be a pretty decent start. But what about those of you that are starting proof-based courses or even graduate courses? What then? This is a bit more complicated because mathematics itself gets less and less linear as you get higher up in your classes. It's not like anybody is taking Calculus 9 to get their PhD. If you want to cut your teeth on proofs, then there's a few elementary ways you can go about this. Personally, I think a great way to get started is to pick up an elementary number theory textbook. Elementary number theory is a bit of a misnomer. Some material is actually elementary, while other parts are incredibly deep. I mean, look at this textbook. You can see what I mean. My favorite book is Strayer's textbook. My last year of undergrad, I was actually down to my last penny and starving, so I had to sell it away, but I really like this book. It goes at a nice elementary pace, and you can learn a lot about how to prove things in mathematics from this textbook and working on its exercises. If you want to check your work or you get confused about anything in a proof-based course, then there are great places to go, like, say, r/learnmath and Math Stack Exchange. Though some people have mixed results on Stack Exchange. Just ask an honest question and show that you've done some work, and people are usually helpful if you go that way. Moving on up, if you want to learn some real analysis, well, I actually have a whole playlist dedicated to it that I will link to at the end of the video. I dubbed the playlist the Analysis Survival Guide, and I talk a lot about more strategies there. For graduate school, the best thing you can do is actually to read your textbook, and don't be concerned about getting too far ahead too fast. Each topic and concept really deserves deep study. Take it slowly and methodically, and that is the best thing you can do for yourself right now. If you're wondering about a particular topic, then there are all sorts of YouTube channels run by professors where you can learn about topics like topology and differential geometry. I was just watching a video on quantum machine learning, which was pretty cool. If you're into operator theory, functional analysis, and data science, well, I have a few playlists here that delve into the subject. I'm also going to be rehashing a lot of those older videos, and I will be adding more topics to that too. This is because I'm working on a book on data-driven methods for dynamical systems, and, well, I'll tell you more about that later. So if you're interested in learning more about real analysis in particular, here's the link I promised you. Otherwise, good luck on your classes, and, well, I hope you have a good day.